All right, here we're looking at section 9 in our algebra review. And in this section, we're definitely going to be looking at some interval notation, but mostly we're going to be solving inequalities. We're really going to be using that interval notation when looking at our inequalities. Then we're going to use different properties of inequalities, then start solving both inequalities and combined inequalities, and then we're going to add some absolute value into our inequalities. Okay, so first let's look at some interval notation. So an open interval is what our parentheses are. So it's all values for which a is less than x, which is less than b. All right, you see I do not have my equal sign here. So if they're parentheses, I don't include the equal sign. So my closed interval, which is the brackets, is where I have my equal sign. It is possible to have just the equal sign on one of those and not the other. So I can have one where I have one bracket and one parentheses. That's totally all right too. So now let's look at this in a table. Okay, so here is the same kind of thing that we were just talking about, and it's also graphed here. So if I have a is less than x, which is less than b, I've got my parentheses, and it's between those two. Then if I throw the equal sign, right, and then here are my two examples where I've got one of each. I can also have things greater than or equal to, and less than or equal to, and also all real numbers. Okay, so there's just a table if we're struggling with what the parentheses look like versus the brackets. Okay, so now we're just going to be writing some inequalities using that interval notation. So here I see I have 1 is less than or equal to x, which is less than or equal to 3. Since those are both equal to's, they're going to use my brackets around both of those values. So let's look at part B. I see that neither of these has the equal to, so I'm going to use parentheses for both. Here I just have x is greater than 5. So here's how I can write this, right? I don't have that equal sign, and I know that I go to infinity here since I don't have an upper limit, so I'm going to use infinity. I never put a bracket with infinity because infinity is an idea, right? That it goes on and on forever. It's not an actual thing, so I can't have that bracket there. So same thing here, x is less than or equal to 1. So again, I know that I go to negative infinity because it's going to continue going forever and ever, but I can have that bracket by my 1 because I have a less than or equal to sign. Okay. So here's our next example. So here I'm given my notation and I have to write the inequality. Well, so I see I've got a bracket by the 1 and a parenthesis by the 4, so I know that I'm only going to have the equal sign by the 1. So I can look at here. See, I see I go from 2 to infinity, but I do not include 2, so I can say that x is greater than 2. So here I see 2 and 3 both in brackets, so I have equal signs for both of them. Now here I'm less than because I'm going to negative infinity, less than or equal to because it's a bracket, negative 3. Okay, so now we're going to use some of those properties of inequalities to help solve some. Okay, so here are just a few that we know. So I know that any real number a, if I square it, becomes greater than or equal to 0. If a is less than b, I can add something to both sides and it will still be true. Same with if a is greater than b. If I add the same thing to both sides, my sign will not change. Okay, so here's my multiplication properties. So if a is less than b and c is greater than 0, my sign just doesn't change. Okay, if a is less than b and if c is less than 0, right, so I now have a negative sign, my sign changes. And then same thing if a starts out greater than b. So just keep in mind what happens when my c is less than 0 if I'm multiplying. Okay, so here's just an example walking through this. So here I have 2x is less than 6. So if I multiply them both, so I end up with x is less than 3. Okay, so I can just use these properties to help me kind of simplify and solve. Okay, so here's my reciprocal property. So if a is greater than 0, then 1 over a is greater than 0. Okay, those are the things we need to keep in mind. And if a is less than 0, then 1 over a is less than 0. Which will start making sense when we see them and we actually use them as numbers too. So now we're going to solve some of these inequalities. So what we always want to do is we want to simplify both sides of the equation as much as we can. Eliminate parentheses, combine as many like terms. Then our goal is to get all of the x's to one side and all of the other terms to the other side by either adding or subtracting and then multiplying or dividing. The only things that change things and make it weird or change the direction of the symbol is if I literally move all of the pieces, or if I multiply or divide by a negative. If I multiply or divide by negative, the sign direction has to change. Okay, so now let's try one. So here I have 4x plus 7 is greater than or equal to 2x minus 3. So let's look at that solution. So both of my sides are pretty simplified, so I can go ahead and start moving all of my constant terms to one side and all of my x's to the other. It's generally, in math, we want to move x's to the left and our constants to the right. So I'm subtracting 7 from both sides and simplifying. And then I'm going to subtract my 2x from both sides to get all of my x's over to the left side and simplify. And then my final step would be to divide by 2. And since I'm dividing by a positive number, I do not change the sign. So I end up with x is greater than or equal to negative 5. Okay. So now I'm going to have some combined inequalities. These combined inequalities are where I have more than one inequality symbol that I'm working with. So here I have negative 5 is less than 3x minus 2, which is less than 1. Then I'm supposed to graph the solution set. So let's see what this looks like. Okay, so I have multiple inequalities here. Okay, it's the equivalent to 2 inequalities. So I have negative 5 is less than 3x minus 2. I also have 3x minus 2 is less than 1. So now I'm going to solve both of those independently. So in order to do that, I want to get all of my x's to one side and all of my constants to the other side. So I'm adding 2 to both sides, and then I just continue to simplify until I have my x by itself on for both of those. Okay, so I first have to take my compound and split it into 2 different equations that I can just solve simply. Okay, so now I can graph my solution because I see that negative 1 is less than x, but x is less than 1. Okay, so now I can graph it, and sometimes graphing it just helps you kind of see, because it's difficult to write this out completely. So sometimes we need the graph to just help us kind of see where our solutions are. Okay, so now we're going to use the reciprocal property to solve this inequality. Okay, so I've got 4x minus 1 to the negative first. And whenever I see that negative exponent, remember that I have to then have the reciprocal of my expression. So I move it to the other side of the fraction. So I notice here that if 1 over a is greater than 0, then a is also greater than 0. So that helps me. So I know a, right, was my denominator here, is going to be greater than 0. Again, just kind of written out. So here's where I use my reciprocal property. Since I know this whole thing is greater than 0, I also know that the denominator itself is greater than 0. So this looks like a simple inequality that I can solve by adding 1 to both sides and then by dividing by 4. So I end up with x being greater than 4. I can also write this in interval notation because I'm going up to infinity. Okay. So now we're going to add in those absolute values and see how we can do with that. So now I have both an inequality and an absolute value. So first, it's kind of easier to think about this as pictures and words. So I'm looking for all points whose coordinate x is a distance less than 4 units away from 0, or from the origin. Okay. So here is my picture. So I see everything in here is less than 4 units away from my 0. So my interval would be negative 4 to 4, not including both of those. So here's another one. So now I'm saying that the distance, my x value, has to be greater than 3 steps away from 0. So again, I like to see this in a picture and see it. So all of these are solutions. So they're more than 3 steps away. So how we write this, right? This is using some of our set notation and our interval notation. So I see that I go from negative 3 to negative infinity, and I also go from 3 to positive infinity. So that's how we're going to write if we have more than one solution that's all included. Okay, so here are a couple theorems that we want to keep in mind. So if I have the absolute value of u is less than a, that's equivalent to being negative a is less than u, which is less than a. Just take a minute to look through these and see if you can follow what the picture of these would look like. Okay, so now we're going to, again, add a few more things in here with my absolute value. Okay, so I see that I just have the absolute value of 2x plus 4 being less than or equal to 3. So again, it's kind of, we're following the same theorem here, right? Oops, this page. So I can write it down as a complex inequality. So I can say negative 3 is less than or equal to 2x plus 4, which is less than or equal to 3. So now I've kind of written my two equations, right, that I can then solve. So now I go ahead and solve both of them. And here we're doing this all in one turn, and you can separate them out and then solve them. But the first thing I noticed to do to get rid of the things with the x is I would have to subtract 4. But I can't just subtract 4 from this. I have to subtract 4 from every single piece on all the different sides. So I can go ahead and do that first. So now I can simplify a little bit. So now the next step would be to divide by 2. But when I divide by 2, I must divide every single term by that 2 in order to get x by itself. So now I see that I have a negative 7 halves is less than or equal to x, which is less than or equal to negative 1 half. And since I was not multiplying or dividing by negative, my sign does not change. I can also draw what that looks like once I've come up with that solution set. Okay. So again, here's one similar. Let's try this one as well. So first thing I have to do is I have to come up with my different statements. Right? I have the absolute value of something is greater than something else. So I can write my statements, and now I just solve both of them by first adding 5 and then dividing by 2. So I end up with my two possibilities. And here's an or because it's not in the middle. Okay? So then I can graph it and make sure that it looks correct and see what I'm looking at there. Okay, so now we're going to look back at these learning targets, make sure that we talked about everything. First we looked at interval notation and the difference between a parenthesis and a bracket. Then I used some properties of inequalities to help solve those inequalities. Then we looked at some combined inequalities where I have more than one inequality symbol. And then I solved some of those that threw in some absolute value as well. So now that we've worked through these and talked through some examples, go ahead and work on your homework for this section.